Welcome to the YouTube channel PCMB Tutorials. I hope you all are fine. Today we will learn class 8 physics chapter Kinematics. This is the one short revision. Though previously we have learned the theoretical part of this chapter, we have learned the full explanation. But today, for refreshing the previous concepts, we are taking this revision session. So let's start with our first question without wasting time. So our question number 1 is: a body covers 1/4 quadrant of a revolution around a circular path of radius k meter. Find the displacement of the body. So this is the circle, this is the midpoint O, this is A, this is B, AO, BO is the radius. Let us solve this problem by some steps. Step 1 will be, in this problem assume that the body starts with the point A, that is the initial position of A. The body covers 1/4 a revolution and reaches the point B as shown in this diagram. That is the final position B. So it's clear that initial position is A and the final position should be B. Step 2. If initial and final positions are same, then the displacement is 0. Remember that whenever the initial and final position would be the same, the displacement is always 0. But here A is the initial position and B is the final position, and they both are different, they are not the same. So we draw a straight line from A to B, AB, line AB as shown in the diagram. To find AB, we join B to O. So the distance between AO and OB and O to B is k kilometer, as it is the radius, and given radius is k meter. So in triangle AOB, from Pythagoras theorem, we'll get that AB whole square is equal to AO whole square plus OB whole square. This will be k whole square plus k whole square is equal to 2k square. AB will be equal to root 2k meter. So the direction of displacement is from initial to final point as shown. I hope you have understood till this. Question number 2 is: an athlete runs in a circular path of radius 14 meter 10 times in 10 minutes. Calculate its speed in meter per second. Step 1 should always be sketching. So 14 meter will be here and the athlete is running. Step 2 will be sorting of data. Means given the radius of the circular path is 14 meter, number of times he runs in a circular path, means n is equal to 10, time taken, that is 10 minutes, that is 10 into 60 seconds, that is 600 seconds. Speed we don't know. We have to find speed. We know that speed of the athlete is equal to distance covered upon time taken. So the distance covered by the athlete in circular path is equal to number of times he runs in circular path into circumference of the path. Step 3, substitution of the terms. So distance covered by the athlete in circular path will be equal to n is equal to 2 pi r is equal to 10 into 2 into pi, that is 22 by 7 into r, that is 14. 7 1s 7 2s. By simplifying this all, we will get 880 meter. So speed of the athlete will be equal to 880 meter upon, means total distance covered upon time. The 880 meter is the total distance covered and time is 600 seconds. Therefore 22 by 15 meter per second is the answer. Now let's move towards the question number 3. That is, an aeroplane flies between two towns separated by a distance of 360 km in half an hour. Calculate its velocity in meter per second. The answer is given that s is equal to 360 km time t is equal to half r, velocity is equal to we don't know. And now velocity, we know that velocity is equal to displacement upon time. That is 360 km upon half hour, that is equal to 360 into 2, that is 270 km per hour. Sorry, 720 km per hour. Seven 20 into 5 by 18 is equal to 200 meter per second. 200 meter per second. Now the objective type question number 4 is, one of the following statements is correct. Option 1, the car traveled around the track at a constant velocity. Option 2, the car traveled around the track at a constant speed. Answer is option number A is correct. The car traveled around the track at a constant velocity because the constant speed and fixed direction. Even though it may have the same speed throughout the direction, it's changing very instant. Therefore, it doesn't have constant velocity. Option number 1 is incorrect. B will be correct. I hope you have understood till this. Now the question number 5. The train traveling with a speed of 20 km per hour applied brakes and acquires retardation of 5 km per hour square. After how long will the train come to rest? U is equal to 20 km per hour. V is equal to 0. Since the train comes to rest, T, time we don't know, retardation is equal to 5 km per hour. Acceleration is equal to minus 5 km per hour. We know that A is equal to V minus U upon T. We have to find T, so V minus U upon A. T is equal to V is 0 minus U is 20 upon A is 5. Minus 5. This we will get minus 20 upon minus 5. Minus will get cancelled. 5 ones are 5, 5 fours are 20. Therefore, time will be 4 hours. I hope you have understood the whole questions till this. Now we have done the revision of this chapter, kinematics, over here. Let's meet in next part with the revision of another chapter. I hope you have understood till this. Thank you for watching.